André is also since 10 years the CEO of Siemens, Belgium and Luxembourg, and combines it with responsibility in Africa, Central West and East Africa. André, please.
I don't like to have a virtual meeting. So, ladies and gentlemen, after the lunch, so a little bit dynamic, I am a representative from a German company, very serious. From Siemens, very serious, grey suit, black socks. I'm trying to explain out something which is not easy. I will have a view of the industrial side of it, and we are investing a lot, 10 billion in the last 8 years, in artificial intelligence, in digitalization, and I propose now to start together. So, first thing is the history we saw. The second thing is we will go together, and I don't know why this is. I think we have, if you have all the same big data in the presentation, you have all the same thing. But let's take on the left, the big data. We will go together define what is an autonomous car. So you drive, you have your driving license, you drive in the street, and you see a lot of data. You see traffic lights, you see publicity, you see people, you see dangerous behaviors, you see factual things, you see unfactual things. That's all the big data you get in. You have your driving license, so you can make the difference between a traffic light and a publicity. Yeah, even sometimes you would prefer to look at the publicity, but you know the difference, you know you have your driving license. You have an industry segment intelligence as I know it. Then your brain will, in consciousness, sort out all the data, because your brain has a tooling know-how in it, in consciousness, and at a certain moment you have a set of smart data where you can drive your car with efficiency and security. And now you have your driving license for 20 years, that is smart data. You have the driving license for 20 years, and you have a learning effect. So it is statistically proved that if you are more experienced in driving, you have less chances to have an accident than if you are 3-4 months your driving license. And you have a reasoning behind it. And you say, if it is -2 degrees outside, and if I go on the bridge, this is danger, and if it's raining, it's danger. And you have a certain reasoning, and you have algorithm in it, which admits you to say, okay, be careful, and then you say also, here there is no flashes, no police, I can drive 160, till the moment you are caught. You can have a self-correction, you look on the line and say, oh, that's a strange guy, I go away, yeah? And you can have also some independent action in the car, and then you are in the way of a mode of artificial intelligence, and you drive an autonomous car. An autonomous car is in fact picking up data, transforming it, and putting it also in some actions. On that is also the digital twin. I will call it, it's a bit of car. Yeah? If we develop today a car, Volkswagen, Porsche, doesn't matter, develop a car, we make first digital model of the car. And with this car you can drive, you can crash it, you can smell it, you can do whatever you want with this model of the car, which is digital. And this we call a model-based simulation. On the moment that we develop the car, we will develop also the factory. And the factory, you will see the factory producing the model of the car. And you will see the factory producing the model of the car with the people in it, not with the people in it, with John, with Jan, with Gert, because we simulate also the operators and robots and everything which is in the factory, dynamic and non-dynamic. Because the code we write for the model-based simulation of a new car is the code that will be téléchargé, that will be deployed in the virtual twin of the factory. At the end, of course, you have to produce a car, so you have to build a factory, and at a certain moment, the real cars are coming out. When the real cars are coming out, every car, or airplane, or it doesn't matter which asset, will have a virtual twin of it. So we'll have 1 million cars, and each million car will have his virtual twin, and this virtual twin is feeding, by statistical based simulation, from 1 million cars, feeding the model. And then I rejoin what Professor Cole says, those all individual patients feed the center to repair a disease which is centrally located. Let's go on this. What are the basics? Basics are data analytics, artificial intelligence, simulation tools, cloud and platform technology, secure connectivity, we saw it in cybersecurity. Design and engineering, we designed a model-based simulation of a new model of a car. We design virtually the factory where it will be produced, and at the end we get the data back of all the cars in the field to refeed automatically the model, the virtual model we designed of the car. And with all the data we have, we can say, hey, this is maybe a Porsche, and it's driving in a forest in the wood. This is normal that after a shorter time than a Porsche driving in Paris has some repair to do, or has maybe some service to do. And then we can have an individual service for each car, or airplane, or it doesn't matter which asset or which object. That's the way it works. We measure sensor processing, image processing, that's called machine vision, speech recognition, and text processing. We'll do now a deep dive on the artificial intelligence module. We have reasoning. This means we can draw conclusions. We can ask also help from others, from colleagues, Dr. Watson from IBM or others. We have learning. This means we implement rules on the data we caught here. We have some creativity. Then it becomes dangerous when you do it on non-technological models. Creativity, we generate hypotheses. And at the end, we have a decision making. And this decision making and all these elements are based on a memory, on a self-learning memory. And that makes the artificial intelligence that the system automatically learns from the past. This is what was called also the base of the neuronal networks. And so if you say to the definition of what is in fact artificial intelligence, it's creating machines that perform functions that require intelligence when performed by people. This is Kurzweil in 1990. At the end, when the cars are in the field, I didn't touch that button. At the end, when the cars are in the field, be the car, be the plane, be it your shoes, be it your eyeglasses, be it your pacemaker, be it your, I don't know what, it can be human, it can be unhuman, it can be technical. You connect it to what we call data gathering, what we call the industrial Internet of Things. By a Mind Connect. This is MindSphere. Then, when your data is in it, we offer applications, standard ones. We offer an environment where this data is protected, where this data is secured, and where you can develop your own strategies on the data. This means you can enrich the data with other databases you have yourself when you buy. If you are a company, you connect your assets wherever all over the world. You enrich them, those data, with other data at your discretion. And on the end, you cannot see it here, but you use the apps. And you use the apps that you develop yourself for your own application. So if you produce compressors, for example, you have millions of compressors outside. You connect the compressor to the Internet of Things, you gather the data, you enrich them with the local factors. Compressor in Ecuador is the same as a compressor in Finland. You make your own apps and you can change your business model of service. This means that you will not offer to the customer, we repair your compressor if it is broken. Now we will predict when a compressor will fall out. Or the provider of the compressor will predict when it falls out. We have here some applications. This is our Siemens factory in André, fully digitalized. We increased the production with a factor 9. We increased by a factor 9. We have less than 1 percentages, than 0.1 percentages on a million pieces produced. This is the semantic factory. And the same personnel as in the factory. So today we have an overcapacity, we could repatriate the Chinese, for example. We are doing an experiment with Adidas, so that you can have your own, you can design your feet, you can digitalize your feet, and your shoes are produced on the measures of your feet. And you can have this for all the industrial lines where we are in. You can have it also for trains. The model of the train, the contract of trains is not in Spain. When the train is broken or stops, we repair. Now we predict the availability of the train, and today with 80% accuracy. That's now more funny. This is good, right? It isn't distorted by a computer. Siemens buys a year more or less 1 billion raw materials, whereof 675 million copper. And we buy this once a year. So once a year we buy copper. So it is very important what the copper price is, you can imagine, on that volume. So we have, of course, analysts, who helps us. and what helps us to define the copper price. One set is 28% accuracy. Trump would say that's a loser, yeah? Total disaster. Yeah? But more of them are about 70%. So we have another who uses neural networks, which is at 74%. We have developed a neural model, which is today at 83%. Accuracy of the copper price. From the moment this accuracy is given, the price is given, the computer shoots and we buy. And we can influence the world market copper price with certain percentages. So that's a very good kept secret when we buy. The same we're starting to do now with other materials. And this system is a closed one. And how we do this? Don't look at the formulas, it makes no sense here, but we connect things which are in principle not connectable. We have more equations than variables, so we cannot solve the total equations. So we reconstruct from the learning intelligence from the past of the market, we reconstruct the variables we miss, and we, at a certain moment, say, okay, that's it, and then we buy. So this difference of 10% is for us 65 million. So it's not zero. The next one is, this is a railway station in Germany. You have 10 factor 90 combinations possible. 10 factor 90. No human can test this, no human can survey this. You have trains which are standing there for days, trains who are broken, trains who are running fast, low, and it doesn't. So we have a solution with a neural network where we can pass the trains on a fail-safe mode into that labyrinth, I would say, of rails. It's better to be safe there. Self-optimizing turbines, that's the key of the artificial intelligence, is that here the machines are optimizing themselves automatically. So from the beginning I said there is a model-based simulation of the turbine. I took a car as an example, and we have hundreds, thousands of turbines outside. Each turbine feeding the model. And our goal is to reduce the NOx emissions because they are penalized in Europe and in the United States. And we have a simulation with autonomous learning. We are better than without autonomous learning. And how does it work? Okay. You have here the turbine, but it can be any other asset with this classical controller. What do? We take the data of the classical controllers into the virtual model of the turbine. This means into the individual virtual model of the turbine and into the mold-based simulation of the turbine. So the individual turbine and into the base simulation. There we make our simulation and we enrich that data with local factors all over the world. This can be Ecuador, has a different efficiency than, for example, Helsinki. And then at the end, for each individual turbine, we refeed the turbine with new parameters to reduce the NOx level. And this is exact, if you listen carefully, it's exactly the same what Professor Cole told for the patients. Exactly the same. So if you apply this type of things, not to technology, but to humans, or to, and this is then the human deep learning, which is very dangerous. I heard also in the press that we want now to have psychologists who talk with robots, who have the psychology of a robot and so on. But what I told you in the beginning, if you drive, you capture data, you have your driving license and so on and so on. If I do this on the Belgian man population, if I know all your data, I can tell you that at the end of this day, probably in this room, 3 people will buy a Porsche in 4 months. From now on 4 months. Because I have all the data and I can do this. This is okay. So if you go on the other one, there's not a joke. If you look at Telefacts on the 8th of November, how Trump manipulated with the Cambridge Institute as of the big data of the electors, 8 November Telefacts, yeah? We'll have a look at that. Yeah? If I took this on politics and I say, how can I manipulate now my electors that after a process of artificial intelligence they will vote for me, I feed them with fake news, I have a fake vote, but it's my vote. 8 November, which is goed kijken. Last but not least, what will be the conclusion of that? The fourth industrial revolution is multidimensional and planetary. This means that it is the first revolution which is not only limited to the Western world or Western world alike, like the 3 other ones. The artificial intelligence will be a total game-changer technology for industrial applications. Where it is produced, where a factory is located is absolutely not relevant anymore. Technologies like deep learning, deep machine learning, and neural networks, they will first disrupt and then rebuild industrial jobs and industries. They will first disrupt and will rebuild. It's also, you can apply those models not only on technical, but also on non-technical. This means on human elements. And this makes it, of course, dangerous. If you influence a copper price, okay. If you influence human behavior, this is more critical. Because you could also apply this in justice. You can also say, I give you 10 people, and you can say, which is the probability that one of them will be a murderer in 5 years? Possible, if you get all the data. Platform business and business flow will challenge asset-based business. This means that the business of tomorrow will be based on platforms like Uber, Airbnb, Netflix, and others, and not based on assets. This means on tangible assets. All impacts apply, repeat employment, societal power balances. At the end, oligopolies in that type of business will dominate. There is one Facebook, there is one Google, there is one SAP, there is one Netflix, and there will be tomorrow maximum in each domain 3 major big players, with of course small and medium enterprises. There will be probably one American-based or European-based and one Asian-based. This is the type of moves that we are doing. With Siemens and Gamesa, we are building a 10 billion wind producer to be in the top 3. With Siemens and Alstom, idem dito. With Siemens, Volkswagen, Umicore and battery, idem dito. The speed of the technical evolution, that's our danger in our society, that the speed of technological evolution and of political decision-making doesn't match. That's the reason why bol.com is in Holland and not in Belgium. Because we couldn't at a certain time adapt our laws, and we couldn't at a certain time be efficient enough to adapt ourselves to embrace that kind of technology. The reaction society has to Industry 4.0 is different. Some, also in Belgium, some wants to tax computers and wants to put a penalty on computers, and the other one wants to embrace it. Of course, you cannot do something else than embrace it. You have to go with your time. But with security, but with some restrictions on ethical items, on human items, because this can go very fast. Last but not least, at Siemens we have approximately 200 people who are focusing only on artificial intelligence, located in those sites, and this is for us one of the 14 core technologies where we're building. Thank you very much.
Thank you very much, André. We learned a lot of you, with a lot of examples about increased production with a factor 9, it's crazy. About the digitalization of our feet for the perfect shoe. About predicting availability of cranes, something for Sophie Dutourdoir to come up. About self-optimizing turbines, great. About predicting who in the room will buy a Porsche. Anyone here? I got a last question, because you're one of the bosses of one of the major technology companies in Europe. I got the impression that artificial intelligence is mainly an item from Amazon, from Google, and from IBM, or for others. What can be the role, or can Europe play a role in artificial intelligence?
We have to make a distinction. You were talking about some viruses. WannaCry, we passed through it as Siemens, which was good. But our suppliers, which has a non-secured and dispersed logistic Internet of Things, which were non-secured, so we had between 3,000 and 5,000 pieces of Siemens somewhere in the world, and nobody knows where. Could be on a boat, could be on a truck, could be in a hangar, could be on the customs. So 3,000 to 5,000. You can imagine how many customers phone and say, "Where is my piece? I'm waiting for my piece." We are here not in iPhone, we are here in industrial business, so factories are standing and you have one client like this. So from the industrial point of view, I think we have in Europe all our role to play. The big industrial lasers are still for a big part in Europe, and we are building up on that. But we need oligopolies, so this means we need strong players to pull on the small and medium enterprises in Europe. On the more leisure part, the fancy part, Facebook, LinkedIn, Twitter, fake news, Trump news, we lost. So we are behind, And nothing is of course forever. Nothing is of course forever. So if we could have a policy in Europe which put us an edge, I would say a political will, unless to defend bastions which are not defendable, but move forward and say we embrace the technology, we have now first signs that factories are coming back from a relocation and that we are producing in Europe at a better price than in some other countries, because political stability is important, because earthquakes are important. In Fukushima, we were hurted with our factories in Fukushima, and this is of course also playing into that game. So it's not lost, it's absolutely not lost, but we have now to move and we have now to go a little bit further. Maybe a last point on that. I was with my CC, my corporation communication director, and I had also an example now, not with the Porsche, but I could say if I have all the female population, I could say that with all the data I know from all the females in Belgium, with everything I had, I could say from this room here, 3 ladies in 4 months will be pregnant. But she said, no, this is grensoverschrijdend gedrag.